Okay, in this project you will design a hollow cylindrical steel storage tank. It'll be welded together to form a closed tank. The volume, so that tells you that all faces are closed up. The volume of the tank must be between this, or it must be this with a height of 4. So let's put that in. We know that this is 4 meters. The steel comes in rolls of 2 widths, 1.8 and 2.1. So let's imagine these rolls. These are huge rolls, right? 2.1 meters is like probably taller than me, like probably this. So that's like one roll is this long, the other one is 1.8, right? So you got to imagine that these come in rolls that are like this, okay? So this is 2.1, and the other one is a little smaller, okay, 1.8. So that's what they are saying here with that statement. The steel will be heated and curved to form the side tank. Okay. Calculate the radius to the nearest hundredth. So 2 decimals, show your calculations, indicate the diameter and the height. Okay, so let's do A first. A is a backwards question. Okay, so we know that we have the surface area of a cylinder. Let me just bring this up so you can see back there. Surface area of a cylinder is what? 2 pi r squared plus 2 pi radius height. We know the tank has a, sorry guys, I misread. This is what? It's not surface area. It's volume, right? My bad. This is surface area. It's not, we're not going to use that. Pay attention, pay attention. Volume is pi r squared times height. Now we're talking. So we know that this is 3.85 and this is pi. We don't know what radius is, but we do know that this is 4. I'm going to do the same thing to both sides to get rid of things. So I'm basically going to divide both sides by pi, and I'm going to divide both sides by 4. And the 4 is multiplying in the denominator, by the way. Cancel, cancel. So radius is going to be the square root of 13.85 over 4 pi, or pi 4. It really doesn't matter. Let's figure that out. So what I do is I go 13.85 divided by, make sure you put that in brackets. Okay, if there's something multiplying in the denominator or some sort of operation happening there, you want to put it in brackets. So that'd be square root of 1.10 something. Let's take the square root of that. That's 1.05. Round it. So now we want the diameter. So to get this, we're just going to multiply our radius by 2. So that would be 2.10 meters. So now we have that. And now it's B. Let's see what we can do there. Determine the length of the piece of steel needed to build the ends and the sides of your tank. Not all parts must be made from the same roll of steel. Show your calculations as well as a labeled diagram. Okay, so let's try this. If I think about it, if I break this one down, right, I will have the top, which is from end to end, 2.1. I'll have that, so I'll have 2 of these, by the way. And I'll have this piece right here, which will be, how wide will that thing be? Like this way will be 4 meters. And how long will it be this way? Like if you had to guess, if this is your sheet here. I know this is 4 meters. And how long will this be? 2 pi r, right? Remember, this is your circumference. If you were to cut it right here, this side, this piece will wrap around this circle. So this is 2 pi r. That's what this is going to be. So 2 pi times 1.05, which is 2.10 times pi, right? This is 6.59, which is 60 meters. Okay, let's read it again. Determine the length of the piece of steel needed to build the ends and the sides of your tank. I wonder if something went wrong here. But I'm just gonna gonna try to solve this problem. If I take the 2.1 piece, and this is my sheet right here, 2.1 gets me this, and then I need another piece here, right? Another piece of that roll to create this piece, and then I'll weld it together like this, because welding allows you to combine pieces. So I'm going to say the length would be, because this is 2.1 this way as well, right? So I'm using the 2.1 roll, which is 2.1 plus another 2.1 plus another 6.6, right? And I need to continue down here another 6.6. You're needed. Plus another 6.6 to make up for this, because it's almost, a roll would make about half of it, right? Because it's 2.1 wide, and we need to take care of this piece as well. So we're going to go another 6.6. So what is this? 4.2. This is 13.2. And so that would be 17.4 meters. And that's obviously not very realistic, because you can't just butt them up perfectly. You would have to add a little bit extra, right? Because if you cut it right here and you cut it right here, the blade takes up a little bit. So sorry about that. So it's a bit of a weird question. I'm not too proud of this one. Sorry about that. But I hope you get at least just like the thinking that went through it. So if I take the 2.1 roll, right, I need to roll it out to make sure I have 2.1 in length, right? Cut it. 2.1, I would cut it here. I need 6.6. And right, that roll takes care of this part. And then I need another 6.6 here to account for that bottom part of the side. Okay, so in theory, 17.4 meters is needed. Okay. The exterior of the tank must be painted to prevent rusting. 2 coats of paint are needed. 1 liter of paint covers 7.5 square meters. How many liters of paint are needed to paint 1 tank? Round to the nearest tenth. Let's do C here. What do we need to know to figure out how much paint to apply? Surface area, right? You need to figure out the surface area. So let's go ahead and do that. I hope this one you could wrap your head around. I'm not too proud of B. It's not worded properly. Okay. But I think I would like you to get used to challenging situations. Okay. So surface area is 2 pi r squared plus 2 pi RH. We're going to cut this off right here. Okay, so surface area is 2 pi. Radius is 1.05 squared plus 2 pi 1.05 times 4. Let me calculate this real quick. You can beat me to it. 2 pi times 1.05 squared, and then 2 pi times, and then you add them up. That's 33.3165 something squared meters that you need, or that needs to be covered. Please don't forget your codes. We need 2 codes. So we're going to multiply that by 2 right away. That's 66.63 something squared meters. And now we're going to figure out how many liters. It's basically saying how many cans, because oftentimes 1 liter is a can. Okay, so it's just a little different wording. Let me zoom in and bring this down a bit. Liters, I'll take what 1 can would need in terms of paint for 2 coats and divide it by 7.5. That's how much 1 liter covers. So I'll go divided by 7.5. That's 8.88 something, which is approximately 9 liters. And to make 100 of these, 9 times 100, right? Actually, whoa, I made a mistake. If you make 100 of these right off the bat, you would first multiply this by 100, and then you figure out how many liters, all right, guys? Because if you are left over with a little bit of paint, you're going to start the next cylinder with that little bit left over, right? So you're saving as you go along. Okay, so, but 9 is for 1 only. 9 liters, 9 cans, quote unquote. How do we know it was liters? Because it told us that 7.5 is the coverage of 1 liter. So that's how we figured out that this needed to be the number of liters. I hope that helped.